about rational and irrational numbers. If you give me any real number, I can put in either rational or irrational. So there's no other categories for all the real numbers. So why do we care about rational and irrational numbers?
It's a good question.
Um, one reason is that if we only dealing with rational numbers, we're gonna have some exact result. Like for example, we're only dealing with whole numbers, we're gonna only get whole numbers or fractions. If we're dealing with irrational numbers, sometimes we have to like not estimate, approximate the result. Like sometimes we're dealing with pi or some square roots. So that's one reason we care about rational irrational numbers. Okay. So first of all, let's talk about rational numbers. So if I take out the norm, so we'll see the root of the rational number, which is ratio. So what is ratio?
A comparison of a part to a whole.
Yeah, but we can. That's one definition. But we can also say it's like a relationship between two quantities, right? For example, we have like for example we have 3, 2, 4, right? So we can also write this ratio as other ways. Like we can write this ratio to a fraction. So it's 1/4, right? Okay, you may ask, is there any numbers cannot? Okay, I'm sorry. So the rational numbers. So rational numbers. So rational number. The definition for rational number is can be written as a fraction. That's why this definition comes from, because the root of rational number is ratio. Okay. So you may ask, are there some numbers cannot written as a fraction? Let's look at the irrational number. What's this prefix means? IR.
Not.
Not. Good. Not plus rational. So it's kind of obvious. The definition for irrational number is cannot be written as a fraction. Okay. So let's take a few examples and see which one they belong to. See if we can identify if they are rational or irrational numbers. First of all, first one, 2/7. Rational. So we have, that's kind of obvious. So we have all fractions, right? All fractions are rational numbers. And second one, 15. Rational. Because we can write all the whole numbers, for example, 15, we can just change the whole number to fraction just by writing 1 underneath it, right? So that's a fraction. So second group, all whole numbers. Okay. Next one, 2 and 3 sevenths, a mixed number. Rational. We know how to turn a mixed number to a fraction. fraction, right? So 2 and 3/7 equals what? 17/7. It's an improper fraction, but it's still fraction, and so that's still rational numbers. Okay, next one. 0.5. Hopefully you realize 0.5 equals 1/2, right? So that's rational. Next one, we don't realize this fraction, but we can change this decimal to fraction, right? How do we do this?
Put it over 10,000.
Yeah. So we know we changed the whole number to fraction by just writing 1 underneath it. We can do the same thing here. So we have 0.3459 over 1, right? And the decimal point is right here, the 1. We cannot leave decimal on the numerator. So we're gonna, what we do is we're gonna move the decimal to the right. So that's 1, 2, 3, 4 to the end. So same thing here. We're going to move the same position here. That's 1, 2, 3, 4. So how many zeros for the denominators?
4.
4 zeros. So that's that one. What about next one? 0.3 repeating.
Irrational.
Rational. Why?
Because it's unending.
I'm sorry, what's it?
It's unending, so.
It's not ending.
Unless you put like.
This is not obvious. This is not obvious. 0.3, but 0.3 repeating is equal to 1 over 3. Right. So 0.3 repeating is rational. So we have another. So the other for decimals is a little bit tricky. So if for decimals, this one, we always ending, like end with some certain of places decimal, right? For this one, even though it's not ending, going forever, but this decimal will be repeating, have some repeating or some pattern, right? So for those kind of decimals, there are also rational numbers. We have another one. If you see a decimal that end or with some kind of pattern, that's a rational number. So this one a little bit tricky. So let's see next one, 3.14. What's this?
Irrational.
Is this pi?
Yeah.
Pi goes on
Yeah.
forever.
This is an approximation of pi. Pi is like going forever. And the pi does not end, does not repeat, and does not have any pattern. That's pi. So that's our first irrational number. Pi. Pi is what about square root of 2?
Irrational.
Irrational. So all the square root numbers are irrational?
No.
No. Which one? Like, can you make an example that is not irrational square root? 25. Yeah. So many, we cannot say all. We say many square root are irrational.
So quick question for you. You say many of those square roots are irrational. Is it true that all square roots of prime numbers are rational?
That is true. So if you have square root 3, so we know square root 2 is an irrational number, right? So what about square root 3? So like, is that case by case? It's a general rule that if you have square root and there's a prime number inside it, that's guaranteed irrational number.
Guaranteed irrational?
Irrational, yeah. Is that good? Okay.
That's good.
So, all like that? I have a worksheet. Do I need to, can I just give them do an exercise real quick?
You're teaching. Do whatever you need.
So I have a worksheet. Please pair of 2 into it.
Hi, Emily.
It's repeating.
It says decimal.
Hate when that happens.
No end. So those are negative doesn't matter. But this is
Is it either or both and?
what? For that? Both, because you have to have a pattern. So decimal with no end doesn't necessitate that it's irrational. It's just pattern part. Those couple together. Because the decimal it doesn't matter if it's positive or negative.
And the rest are?
81.
Nine.
Yes, it is.
Heck, that's like smart. The presentation things going at this point.
Everyone done?
You don't have
let's
those
just go
back
over
here.
real quick. A square root 9.
Are you talking about the handouts in the different groups?
Yeah.
Yeah, those in the end we have by grade level.
Number B, 0.3.
Rational.
Square root 8.
No.
Irrational.
D, negative 3 over 8.
Rational.
Number E, 3.17. I'm sorry, 3.14.
Irrational.
3.14?
3.14, yeah.
Is it like, are you saying pi? Or?
I'm saying exactly on the paper.
Oh, well, then that's
3.14.
rational.
That's right. Don't get.
Tricky question.
Frick me.
F.
That was a trick.
Number F is square root 36.
Rational.
Good. Number G, 3 over 14.23.
Rational.
Okay.
What is it?
8, G, right?
Yeah.
That's rational.
How is that rational?
Because you can do the same thing as just
Wouldn't that be
moving the
like-
decimal, for the denominator and on top.
Well, wouldn't that be like a fraction on top of a fraction?
It's 3 over 14.33, right?
Right.
decimal on the denominator, right? We don't want decimal. So we're gonna change this decimal to whole number by moving two places. 1, 2, 1, 2. So that's a fraction.
Got it.
So number H is square root 81. I 3 pi over 2. Irrational. Yeah. Last one 0.6.
Rational.
Rational. Yeah. So hopefully after this class you identify any real number. So you can say, oh, that's a rational number and that's an irrational number. So rational numbers basically just you can, if you are confused, just apply these two laws or rules. The rational numbers you can be written as a fraction. Irrational numbers cannot be written as a fraction. If you apply these two rules, you identify all the real numbers.